The speakers for this session are Martin Eian from Mnemonic and Fransen from TNO. Martin is also a member of the Europol EC3 Advisory Group on Internet Security, and Frank is a senior scientist at TNO who is technical coordinator for SOCCRATES. The session is titled SOCCRATES, Automated Security Decision Support for SOCs and CSIRTs. Welcome to Martin and Frank.
Thank you. Does this work? No? No? Okay. I'll try to speak loudly. Here's an outline of our talk. So Frank will start with an introduction to the SOCCRATES project and the platform, just to set the context, to let you understand the next part. Then I will talk about the three main innovations we want to share: machine-readable model of the infrastructure, automated security reasoning, and automated response. And for each of those, I will explain what we needed, what we did, and what we learned. And then we will wrap it up with some general lessons learned and takeaway. So, introduction.
Okay. So SOCCRATES is a Horizon Europe research program, project within the Horizon 2020 research program. It's an innovation action, which means that the result of the project has to be demonstrated in a real-life environment, or an operational setting. And it ran for 3 years, from 2019 till end of October last year. It was coordinated by TNO, and I was technical coordinator, and Martin was work package leader and provided with a lot of insight and guided the work. So what we set out was to develop and implement a security automation and decision support platform that enhances the effectiveness of SOC and CSIRT operations. We didn't want to eliminate the humans in the SOC, but we wanted to help them support with a lot of automation to speed up the process. To design that platform, we defined 5 use cases. The first use case was responding to a detected ongoing attack, so automatically analyze what's going on, identify the impact, come up with courses of actions, and be able to execute them. Use case 2 was responding on reception of new threat intel. So you learn of a new attack, how does that affect our infrastructure, how can that be used, and what can we do to mitigate that threat. The third use case is responding to the discovery of a vulnerable asset in your infrastructure. So then we want to know what is the impact if that vulnerability is compromised. What is the exposure of that vulnerability? Can that vulnerability be used to more easily compromise critical assets within your infrastructure? And then if that's the case, well, what can we do about it if, to reduce that impact? Of course, patch, but if we cannot patch immediately, what can we do in the meantime? Use case 4 and 5 are kind of similar as use case 3, where the use case 4 is responding to a configuration change in a machine which might introduce a vulnerability, and sometimes it splits over to the next step. And use case 5 is when you introduce a new system in your infrastructure. Somebody is again clicking in another room, I think, because I'm not doing anything and it's over. So another way to present these use cases is that use case 2 to use case 5 is everything that happens before an attack. Yeah, so how can these new informations on a new vulnerability or a new threat intel be mitigated by courses of action and executed? And then use case 1 is actually responding to an incident. So it's an incident response process where you have normal process steps like detect, analyze, contain, eradicate, and recover. Within the SOCCRATES project, we focus only on the steps detect, analyze, and contain, and have courses of actions for the containment. And what we quickly learned when we analyzed this is that the courses of actions for containment have to be directly enforceable, whereas when you do the courses of actions for use case 2 to 5, there can be a project where you introduce new segmentation of your network, or two-factor authentication, or do some security awareness training. Of course, you also have post-incident improvements, and they're kind of the same, the courses of actions, as what you have within use case 2 to use case 5. So there is some differences there. For each of these use cases, we have the same approach in how we do the analysis on them. You have the monitoring phase that triggers the analysis, and in the analysis phase we want to automatically assess the threat, the impact, and present this as situational awareness to the user, to the SOC analyst. In the next step, we are automatically analyzing what options there are for taking courses of actions, and we present it to the analyst with some information on the negative effects of these courses of actions or the positive effects, and that he can choose, and then the next step is executing those courses of actions. For those who are familiar with MAPK or OODA loop, that's the flow that we have for processing these things. The platform looks like this. So we identify all these components that we have developed as the dark blue colors here. We're not going to describe all these components, but we want to focus mainly on 3 innovations, like Martin already presented in the introduction. So infrastructure modeling, create an actual machine-readable model of the infrastructure, and we need this for the next one, the next main innovation, which is automated security reasoning. Automatically analyze the threat, and we do this with a technique called attack defense graphs, based on that model of the whole infrastructure, where you can calculate attack paths, how an attacker can move laterally through your infrastructure. Another thing that we want to do is real-time business impact assessment. So when, again, somebody's clicking on it. So when you have a compromised asset, what is the impact of that asset to my business? Which business processes and which business applications are compromised, and how bad is that for the infrastructure? And the third innovation is automatic generation, analysis, and execution of the course of actions. And we have several components that contribute to that one. And this is where I hand over again to Martin.
Thank you. So that was the introduction.
See?
I went back. That wasn't me. That was the introduction. And now we're moving on to the main innovations. Are we fighting with the other room now?
Yeah.
We won. All right. So the first innovation, machine-readable model of the infrastructure. So what we needed was, first of all, several of the components that Frank presented now, they need access to a machine-readable infrastructure model. And one example is this attack defense graph analyzer that simulates how an attacker could traverse the infrastructure. In order to do that, it has to have a model of the infrastructure. Furthermore, we needed the ability to collect and correlate data from multiple different sources, such as a vulnerability scanner, Active Directory, IP address management systems, configuration management databases, and so forth. Very rarely you see all of this information in one place. So we needed to grab it from multiple different places or sources and fit it all together. And finally, in order to trigger these use cases, we needed the ability to detect changes to the infrastructure and then trigger the relevant workflows. And that applies to use case 3, new vulnerable system, 4, configuration change, and 5, new host. So what we did very early on, when we started mapping out the requirements, we saw that what we needed was a pretty good fit for something that Mnemonic developed in a previous project, which we called ACT, which was a threat intelligence platform. And that's shown in the dashed red line. That was not supposed to happen. Okay. In the dashed red line here. So ACT consists of a core graph database, a REST API that provides machine-readable information, and a graphical user interface built on top of the REST API. And furthermore, it has a built-in triggering engine that can do user-defined actions when a specific condition occurs. And that triggering engine was something we could use for the third need, the ability to detect changes and trigger workflows. But in order to solve the correlation challenge, is this readable? Oh, it doesn't disappear.
Text is too small.
We needed to design a schema or meta model of the infrastructure. Because in ACT, all objects are unique by type and value. So if you have an IP address object, and you add you add information to that object from one adapter or one data source, and then you add more information from another data source, then all of that points to the same object. In order for that to work, we needed to design a data meta model or schema, which you can see here. So, as an example, a vulnerability scanner would typically add information about the nodes in green here. So, obviously vulnerabilities in the bottom left, what kind of software they affect, which hosts that software runs on, and what kind of IP addresses those hosts have. And then the Active Directory adapter could add information about the nodes in yellow. So group policies, groups, users, organizational units, but also hosts. And that means that when you get the information from the vulnerability scanner and you get the information from Active Directory, they both contain the host object. So that's the key point here. We needed overlap between all the different data sources, which enable this implicit or automatic correlation without having to explicitly synchronize every adapter. So what we learned, the first and kind of surprising feedback we got from SOC analysts was that they thought that the most important feature here was the ability to detect infrastructure changes. In the beginning, we kind of thought, okay, responding to a detected incident would be most important. But the thing is, most mature SOCs are pretty good at doing that already. So their blind spot was more with, we have a new vulnerability, we have a new system. What does that actually mean for the business impact and the infrastructure impact? So they thought that was a more important feature than responding to an incident. The second one, that we designed a system that should be able to do automatic correlation. That works well in theory. And then you have to deal with the real world. So you get a host name from the vulnerability scanner, which is a fully qualified domain name. You get the same from the Active Directory adapter, which is the net bias name, and then you break the correlation. So it's still a major challenge, but it's solvable. And then finally, the scalability. This works well in a demonstrator environment. We also tried it in an operational environment with, I think, around 12,000 hosts. The infrastructure model was able to deal with that, but that caused severe problems further out in the analysis chain. On to the next one, automated security reasoning. We needed the ability to run attack simulations on the infrastructure and the ability to do real-time business impact assessment, as Frank mentioned. Not only on the compromised asset, but also on the business impact of the proposed courses of action for responding to it. So what we did, in the top left, you can see the model of the ICT infrastructure, which is what I presented in the previous slide. We used one of the partners in the project took an existing product, which is a proprietary tool called SOCCRATES, and modified it to work in this setting. So that component in the top right takes the model of the infrastructure and then simulates how an attacker could go either from the internet or from a known compromised host to high-value targets in that infrastructure. So the inputs are basically the infrastructure model, the attacker behavior, and the list of high-value targets. That can also be done in reverse. So going from the internet to high-value targets is forward-looking. You can do it backward-looking. If you discover a compromised host in the engineering department, then you might want to know, how did the attacker get there? What's the most likely path they took from the outside into that compromised host? And that can be simulated by putting the attacker on the internet, setting that target host as the high-value target, and then running the same kind of simulation. So in SOCCRATES, we did both the forward-looking and the backward-looking looking analysis. Then furthermore, we developed a business process model and a business impact assessment tool. So that's a combination of the infrastructure model. The business impact assessment tool takes a combination of the business process model and the infrastructure model to try to calculate what the business impact of infrastructure events could be. And not just what you're observing, but also based on the attack defense graph analysis. So you will get the potential business impact of this vulnerable system that you just saw, but you will also get a business impact assessment of the most likely next steps for the attacker. So if that vulnerability leads to a high probability that the attacker will compromise a high-value target, then that will be reflected in the business impact assessment as well. So what did we learn? Feedback from SOC analysts was that especially this attack defense graph analysis gave them unique contextual understanding, because you're no longer just looking at the point event or a single compromised host. You start reasoning about what most likely happened before and what's most likely to happen afterwards. And most of the SOC analysts we talked to, they didn't really have tool support to do that kind of analysis. The second one is that this kind of security reasoning needs to be event-driven and asynchronous. And that's mostly because of performance and scalability issues. As I said, we ran into trouble when running this in a big, or not big, but reasonable operational environment. And the biggest problem was the attack defense graph analysis. So in order for that to work at scale, you have to pick it apart, compartmentalize, be able to rebuild parts of the model, simulate parts of the attack defense graph. And that's something that's being worked on, but it's not ready for prime time as the situation is now. And then finally, thought I'll do some audience interaction too. How many of you have access to machine-readable business process models in your organization? Just raise your hand. No? Okay, that kind of underlines my point, because I don't know anyone else who does either. And that's a kind of chicken and egg problem, because why would you spend a lot of time and effort and money on creating these machine-readable models if you can't use them for anything? So in the project, we had to do this manually, but I think the solution to the chicken and egg problem is that you need to demonstrate the value. This is what you can use them for. So what we tried to do here is important in demonstrating that you can actually use these machine-readable models for something. And that will hopefully drive people to consider making them. On to the last main innovation, automated response. What we needed there was the ability to generate courses of action. We needed the ability to rank them, to not only according to the effectiveness or how effective that course of action would be at addressing the security event you observed, but also on what kind of business impact will that course of action have. And just as an example, if you're running an online web shop and you're suggesting a course of action where you unplug everything from the internet, that probably applies to a lot of other businesses as well, but that's going to have a pretty high business impact, so it's probably not something you want to do unless you absolutely have to. And that's why it's important to weigh them against each other. You need something which can address the threat, but at the same time not be catastrophic to your business. And the last thing we needed was the ability to automatically execute these courses of action after a human analyst says go, of course. That's optional, but that's something we implemented. So what we did, we developed a course of action generator What that does is to iteratively use this attack defense graph analysis and then change the security controls in the simulations until it starts converging on a near optimal course of action. That generates these generic countermeasures that Frank presented from use case 2 to 5, like deploy some new security control, do a new segmentation of your network and so forth, things you typically don't have time to when you're responding to an incident. And the second one was the response planner to address use case 1. You need to do something right here and now, like isolate a host, block an IP address at the perimeter, and so forth. So that response planner generates these direct enforceable or containment courses of action. Both of them output playbooks formatted in the Cacao standard, and they use the OpenC2 standard to signal automated response actions. So we implemented this in a demonstrator environment. Once the SOC analyst says go, or selects a course of action, that's sent to an OpenC2 proxy calling an AWS Lambda, which, for instance, isolates a host in the demo infrastructure. What we learned that we need containment courses of action. That's not something we considered at the beginning of the project. It was pretty apparent early on. The second one is it's extremely important that the analysts trust the platform, and I'll get back to that in the main lessons learned. And the last one is user interface is important. You need to actually make the analyst understand what they're looking at. It's not sufficient to have an optimal course of action if the analyst doesn't understand why. Right.
Lessons learned from and takeaways. So lessons learned. First, lessons learned from running a large, ambitious project like this. So the first thing that we quickly learned is that if 10 partners develop software and it has to be integrated, and everybody is using their own techniques for developing these things, it's hard, particularly when you want to deploy the software in an integrated manner in 3 or 4 different environments. So what we did was set up a GitLab environment where everybody was putting their code. We used containerization and Kubernetes to actually run it. And eventually, we got the platform running, most of it in Azure Kubernetes service. And then some components were running on AWS as standalone services. And that integrated with the next component, an infrastructure under control. That was set up also in AWS. But to build this, we started actually too late with developing this infrastructure. So our lessons learned is do this in the beginning. Because when we had this infrastructure and we were able to deploy all the software and then actually test it, we could actually see how it actually is working. If we would have had this available, let's say halfway in the project, then integration testing would be much faster, and then improving on how the user interface would look like. We should have had time for that then in the beginning. But what we did for the infrastructure under control was take an Archimate business process model in Archimate language from an Arch Assurance case and set up the whole infrastructure that resembled the technical part, and then we used the business process logic there to do the business impact accordingly. So eventually we got the whole thing implemented and demonstrated in that environment. Another thing that we learned is when you actually deploy the software in a real-life setting. We had 2 demonstration environments. One was at Mnemonic, the other one was in Vattenfall and their SOC. It's hard, and you have to take sufficient time to actually implement and integrate this platform into an existing environment where you have your own SIEM environment, your own vulnerability detection software that has to be integrated. So plan sufficient time for that. But above all, like Martin already said, there are some performance issues in their infrastructure under control in our test environments. The scope was it's less than 25 devices we had. But at Mnemonic, you had a 10-fold or 100-fold of that. And then you start running into performance. So in your test environment, also do performance and stress testing capabilities there to make sure that when you actually move to an operational environment with your research infrastructure, you can actually run it.
Right. The other lessons learned is what we learned about security automation for SOCs and CSIRTs. So the first one is kind of a repetition, but there was pretty unison feedback from the analysts that tested this, that this kind of approach provides a unique contextual understanding, both by looking forward and backward on probable attack paths, but also on seeing the potential business impacts of events in your ICT infrastructure. And they also then highlighted that this is even more useful for new vulnerabilities and infrastructure changes, because they didn't have good visibility there to begin with. The second one, here's something completely new that we haven't talked about. Frank showed you the overview of the platform, and in the middle is an orchestrator. And that orchestrator has a machine-readable workflow for each of the use cases. And we also got feedback that these workflows had a value in themselves, because when you reach these decision points, the situational awareness and the option awareness, you force the analyst to take a step back and reflect on the threats, on the events, and on the possible courses of action. That was also a bit surprising to us, but after the fact, it seems kind of obvious. And the last one, and in my mind, the most important one, analyst trust is paramount, because unless you're willing to let the computer make business-critical decisions for you, if you think that's okay, then analyst trust doesn't matter. But if you want a human to have the last word, it is not sufficient to tell them what to do. You need to explain why. You need to provide clear and visible evidence supporting the proposed course of action. And that's maybe one of the weakest spots of what we did in SOCCRATES. We didn't properly address this. We know better now. If we were to do it again, that would be one of the core parts of a project. So the key takeaway here, security, automation, decision support can enhance the effectiveness of SOC and CSIRT operation. It's possible. We feel that we demonstrated that in a demonstration environment. We partially demonstrated that in a real operational environment. But this is not something that's ready for production. And the SOCCRATES platform most likely will never be. It consists of both open source components and proprietary components, and is not being actively developed further. But what it is a stepping stone to let others get further on automated decision support for SOCs and CSIRTs. And the Socrates.eu webpage contains lots and lots and lots of information. There's a vision paper, webinar recordings, lots of documentation, a platform overview with links to all of the components. And for those that are open source, it points you in the direction of the open source repositories. So if you're interested, please have a look at this webpage. It's got, I don't know how long it's going to be up, like 4 years?
Couple of years.
Couple of more years. Go check it out. We don't have time to explain or to present all the stuff we did during these 3 years. And we're planning to go to the Automation SIG tomorrow. Hope to see some of you there. If you found this interesting, if you're interested in taking the next step on automated decision support for SOCs and CSIRTs, please contact us. I will be here all week. Frank will be here until Thursday evening. And we're happy to discuss or answer questions, both on email and in person. That was all from us. Thank you.
Okay, does anyone have any questions?
Hi, great talk. Thank you. Very interesting problem, very difficult problem. I have a question. Well, I have a lot of questions, but I will bother you afterward. But main question that I have is, when you consider automated course of actions, Do you also have a way to formalize and take into account the impact that additional defensive actions that the system would take, how they would impact the utility of the system? So would that remain useful? Because of course, if you isolate a box from the network, well, it's safe from network-based attacks, but it's useless. It won't do what it was supposed to do. Did you consider that within the scope of this program?
Short answer is yes. That's what the business impact assessment does, basically. You have it computes not just the impact on the, for instance, if you have an ongoing attack, you have a proposed course of action. It doesn't just compute the impact of, or the effect on the attack, but it also computes the business impact, which is, as I understand it, what you're talking about. How does this affect our business processes? It doesn't have to be about money. It could be about human lives or any other metric. But yes, that's part of the calculation. And we use a metric called return on response investment, or RORI, which factors in both the effect of the countermeasure and the business impact of implementing that countermeasure. So good question, but we already thought of it.
Thanks for the talk, really, really interesting. My name is Eian, I'm from the automation SIG, so I'm really happy that you plan to join. I think it would be really interesting also to hear like your experiences of adapting the framework to MSSP or to a SOC, and like the troubles that you had, and like learn in more detail about that. So I would really encourage you to share that with the automation SIG.
I'm super happy to talk about that. I'll try not to be too frustrated. We were the MSSP pilot site here, and we spent 5 of the 3 months scheduled for the pilot on getting things up and running.
Thanks.
Any further questions?
Hi, thanks. So super interesting approach. Were you also able, or do you think it's feasible to take it one step further, right? So from the business impact analysis to also maybe even then calculate financial impact, or to link it closer to basically what you do in terms of risk management, right? So first of all, also of course reactive after an incident happened, but maybe also even like forward looking, right? What could an attack unfolding on this and this system mean for us as a company from a financial perspective?
Yeah. What I would say, our answer to that is, yes, it would be interesting, but it's all about the data that you have available. And as Martin asked you, who of you have a business process model available that is machine readable, or a tool with Archimate or BPMN models of their processes? If you do have that, and we are working with a company in the Netherlands who provides such tool, then you have to include all this information in it. Now, what we currently do is, having scored from a business impact assessment on the CIA categories 1 to 5, so it's quantitative, but it's not financial yet. But when you have an asset on the technical layer and you say this is compromised, you can go all the way up following which business application and business processes are affected by it, and how that whole process chain is then affected, and that you can then provide some information on it. But it's, you do need to have financial information on that. But yeah, we are looking into these challenges, but it's hard, and you have to have this information available. And again, it's also, you can even go further and say, well, it's not just them, it's at this moment, what is the impact now? Because the business at this moment is doing something else than in the weekend, or in 2-3 weeks of time. So having that information available for doing a real-time business impact can make it much more, yeah, qualitative and valuable.
All right, thank you to Martin and Frank, and just a reminder to complete out the session survey in the mobile app. Thank you.